So up next we have the last UF team, and once they present, we'll head over to lunch. So the UF team, Los Amantes del Agua, they will be presenting on the application of biochar as an adsorbent for the industrial effluent water treatment. I'd like to welcome Tamid, Kokil, and Darren.
Is there a clicker? Yep. Okay. Good morning, everyone. So, Cuba is a land of many natural beauties. One of those natural beauties is the beautiful waterways and riverways that run through it and breathe life into it. However, now, we cannot say that anymore. With its inception of its highly industrialized endeavors, Cuba's beautiful waterways are now laden with metal-laden toxic waters. And one of the prime victims of that is the Almendares River. The Almendares River lies in northwestern part of Cuba, and it's a very important river for Havana and Cuba. We are Los Amantes del Agua, and we will be proposing a cost-effective, and efficient treatment to treat industrialized effluent using biochar. I'm Tahumid Ibnat, fourth-year environmental engineering undergraduate from the University of Florida.
I'm Kokil Bansal, and I'm a second-year graduate student studying environmental engineering at the University of Florida.
And I'm Darren Walshaw. I'm a fourth-year undergraduate studying environmental engineering at the University of Florida.
Let's get started. So, as said before, the Almendares River is located in northwestern part of Cuba, and it lies directly atop the Vento Aquifer. This is a very important aquifer for Havana. Next slide. So, according to a 2005 study done by Cuba's Higher Institute of Applied Technologies and Sciences, there's been high quantities of heavy metals such as lead, copper, and zinc in the Almendares River. According to the study, this is due to the unprotective and neglected measures against contamination that's discharged directly into the aquifers, mainly from the industries. Now, the importance of the Vento Aquifer. This aquifer provides about 50% of the potable or drinkable water for Havana's population. This Vento Aquifer is directly connected to the Ejército Rebelde Dam, which means that pollution directly from this Ejército Rebelde Dam can pollute the Vento Aquifer. And according to many research, this aquifer has already been contaminated with a lot of pollutants. So, there are 4 phases to this presentation. Phase 1 is relevance to Cuba's infrastructure. Phase 2 is the industry of focus. Phase 3 is the analysis of the biochar technology, which includes the production method and the filtration method. And phase 4 is the cost and benefit analysis. So, our focus will be on the town of Cotoro, as you can see upstream right there. These colors indicate the levels of contamination, with red being such high, extreme amount of contamination. Now, the Almendares River travels north and northwest. So, whatever pollutant arises from upstream, such as from Cotoro, where our industry is located, these contaminants will be transported directly to the port areas downstream. And downstream is the Regla, which is a port area, and the Habana Vieja, which has a high population density, and thus potable water, clean water is necessary. So, as we said, clean water is necessary, and Almendares River has been already known and shown to be highly contaminated, also stated by the UM team. It's highly contaminated, and thus leads to contamination, bioaccumulation, and biomagnification in the food chain and the trophic level. And basically it means, over the course of time, these heavy metals and contaminants can be ingested and eaten and consumed by these fishes and other life forms that thrive in the Almendares River, eventually to be eaten mainly by humans, or even like these fishermen right here, who take pride in their snakehead fish, but they don't realize the problema muy grande, but it's more pesada. But in the more serious case, these humans don't realize that when they eat the snakehead fish, which has probably a lot of bioaccumulation and biomagnification of these toxic heavy metals, already the #1 rate of death in Cuba, according to the 2012 study by Ministry of Health, cancer is the largest cause of death in Cuba. So we can already see, we just cannot overlook the fact that the heavy metals in this river can be a part or a cause of this death. So phase 2 is industry of focus. So we are focusing on a metal smelter. It's formerly known as the Antillana de Acero, or the Jose Marti Steel Factory. It's a steel smelting factory upstream in Almendares River, near the town of Cotoro. Now, let's go over the town of Cotoro. It's a small municipality, about 80,000 people in population. About 50% of its land is used for agriculture. Now, we already said that the Almendares River is very much polluted. Just think about the water being polluted, and then this water being used in part for irrigation purposes. So these metal contaminants are being ingested not just through water, but also through their foods. And there's a specific reason we chose this particular metal smelter. It is because this is upstream in the Almendares River. We already told you that water travels north and northwest in the Almendares River. Thus, if we wish to kill the source or decrease the amount of contaminants in the Almendares River, we must start from the top, upstream. Thus, this metal smelter is very important, upstream. So the Jose Marti Steel Factory. Let's give a little history. It was built in 1959, and it has been in operation since then, producing about 200,000 tons of steel per year, with a capacity to produce about 500,000 tons of steel a year. Now think about how much effluent it must be releasing every single day. About over 500,000 gallons of effluent is released every single day from this industry. Now, looking at the dilapidated state of its furnaces, we can kind of say that most likely the effluent that's released directly into the Almendares River is not treated. Now, these numbers definitely might strike you. Definitely quite a lot, because the average concentration of these heavy metals, copper, zinc, and lead, that's being released per effluent from this industry alone, let alone the so many other industries that are along this 45-kilometer stretch of this river and its tributaries. The EPA contaminant level, comparing to it, much, much higher. We can see the EPA contaminant level, which is a measure of the maximum level of these contaminants in the water before it can cause negative health effects to humans. I think the numbers tell you enough, and no wonder the number of death caused due to cancer is so high. So I will hand this over to Kokil Bansal for her analysis of technology.
Thank you, Tamid. So, we know Cuba has a very rich agricultural industry, especially being one of the primary producers of sugarcane in the world. Now, this sugarcane is crushed and the juice is released, which is used to make sugar. But the waste part of this plant is bagasse, which is produced in high quantity. So around 1.8 million tons of the sugarcane produced, 540,000 tons is the bagasse. This bagasse has high calorific value, and which is why we want to use this to produce a biochar, which is high carbon and very fine particulate matter. Next slide. So the reason why we love biochar so much is because of this concept known as surface area. So as you can see, this is a rectangular prism. Now as the size has decreased, the surface area increases, which means that the number of surfaces for the contact, for the contaminants to come in with biochar has gone up drastically. So the pollutants can be removed from the water, thus the clean effluent can just be sent. Next. So now biochar has a surface area of around 600 meters square per gram, which is 60 times the surface area of that of bagasse. So if you have 10 grams of this biochar, the surface area in this is equivalent to the surface area of an entire football field. So you can imagine the possibilities we have of removing the contaminants. So this will be produced in our portable biochar batch kiln, which is developed on-site, which will be produced on-site. And go back. And the temperature is around 500 to 550 degrees Celsius, and the particle size is less than 2 millimeter. Now, one other plus point of using this process is the fact that it can produce synthetic natural gas, which can be used for electricity generation as well. So this is our monomedium biochar filter design. And so in this process, we have a biochar. The untreated effluent water from the industry will pass through it, which is laden with lead, zinc, and copper. This lead, zinc, and copper will get absorbed on the surface of this biochar, and the clean treated water can be released, it can be stored, and be sent back to the industry, thus closing the loop on the entire treatment process. The efficiency that we get from this process is copper is around 95%, lead 90%, and zinc 85%. I'll hand it over to Darren, who's going to talk about the cost.
Thank you. So the initial cost for our operation at Jose Marti Steel Factory will total approximately $272,000. This includes everything from excavation to installation of the entire operation, as well as the biochar batch kiln. Now, with any ongoing operation, there exist annual costs. These costs will total approximately $44,000 per year. When we total this together with the initial costs, our 3-year cost of operation is approximately $400,000, as well as a 10-year operational cost of approximately $630,000. However, this is merely the beginning of our end goal. Ultimately, we want to expand this operation down the entirety of the Amantes River while also expanding into Havana Harbor. In the picture you see here, each red dot represents one known factory. In the Amantes Vento watershed, there exist 20 known factories. If we assume at least 30 more around Havana Harbor, this equates to at least 50 factories that we can apply our treatment to. If we assume an initial cost per unit of $272,000, this brings our initial investment to $13.6 million. A 3-year operational cost will be approximately $20 million, as well as a 10-year operational cost of $31 million. But what can Cuba expect to gain from such a project? Well, it's important to note that environmental remediation, particularly that of water quality, has been identified as one of the primary concerns by the United States in repairing relations with Cuba. So over time, improved water quality in Amantes and Havana Harbor will likely result in reducing cancer rates closer to the global average in the surrounding population. This population includes the town of Havana, as well as the entirety of the Amantes Vento watershed, which equates to roughly 2.5 million people. Furthermore, with improved water quality, we can expect to see an increase in Cuba's tourism sector and therefore the revenue generated from such. Now, quantifying these benefits, we will begin with the reduction in cancer rates. Referencing numerous sources, some generated from within the island, some from outside, we obtain an excess range of cancer rates anywhere from 13 to 20% above the global average, largely due to the industrial activity without regard for protective measures to the environment. If we assume a conservative reduction of 13%, that equates to 600 fewer people in this area alone who will not suffer from cancer. At $10,000 per complete treatment of cancer, this equates to $6 million in savings over time. Furthermore, Cuba benefits from $2.1 billion in annual revenue generated from the tourism industry, 40% of which is generated directly in Havana. If we can see even a 0.5% increase in annual tourism due to our project, we can expect a $4.2 million in extra annual income generated for the local economy. Over a 10-year period, this equates to approximately $50 million in supplementary revenue, well over the 10-year operational cost for our project. In order for Cuba to achieve its full economic potential, the country must give its citizens the quality of life they deserve through the environmental remediation. We will achieve this environmental remediation through targeting the most concentrated pollutants at the source, using the most economically feasible methods of filtration possible. Once fully expanded, our project aims to sequester the cause of excess cancer rates in the surrounding area, while recovering and further enhancing the natural aesthetic beauty that drives the nation's vital tourism industry. With that, we conclude our presentation on the application of biochar as a source treatment for industrial wastewater. We would like to specifically thank Cristina Ortega and her team for their previous work in this area, which provided us with great insight while conducting our research. We would also like to thank our industry advisor, Jerry Fernandez. He has provided us with invaluable assistance throughout the entirety of our project. Lastly, we would like to thank everyone who had a hand in putting this event together and allowing us the opportunity to present in front of you today. Thank you.